In this section, we're going to learn about a series of well-known principles in the world of software development, which are often even asked about in job interviews. These are the principles called SOLID. What are these SOLID principles? Well, they are a set of principles that, when used together, will allow us to create better code that is reusable, robust, and easy to test as well. As a point to consider, these principles should be used, as I mentioned earlier, together, since applying them individually may not give us the best results. Another important point is that there is no order in their use, meaning we can use them as we need them in our projects, without necessarily having to apply them sequentially. Now, let's examine why they are called SOLID. Basically, SOLID is an acronym of a set of acronyms, which are SRP for the Single Responsibility Principle, OCP for the Open-Closed Principle, LSP for the Least Cost Substitution Principle, ISP for the Interface Segregation Principle, and DIP for the Dependency Inversion Principle. If this is your first approach to the SOLID principles, these names may seem a bit confusing and even complicated. But throughout this course and this specific section, we will understand each of these principles and how they can help us improve the quality of our code through various practical examples. Let's start by studying the Single Responsibility Principle. This principle is attributed to Robert C. Martin, known as Uncle Bob, and the fundamental principle states that a subsystem, module, class, and even a function should not have more than one reason to change. This definition may seem simple or confusing if you have never dealt with it before. For example, you might wonder, what does it mean to have one reason to change in a system? Let's analyze this principle in more detail, but first, let's study a couple of concepts that are closely related to the Single Responsibility Principle: coupling and cohesion. When developing a system, you may have wondered, where should my code go? Perhaps, as a good developer, you are always looking for the best way to organize your code to make it easier to read, understand, and change if necessary. There are some general recommendations that we can take into account to achieve these goals in the code and that are related to the Single Responsibility Principle. The first recommendation is to keep things that need to change together as close as possible in the code. The second recommendation is to allow unrelated things in the code to change independently. Finally, you should minimize code duplication, as long as it does not break the system's correctness. These objectives are closely related to the terms applied to code called cohesion and coupling. You will often hear that the ideal is to achieve low coupling and high cohesion, but what exactly does this mean? To understand this phrase, we first have to study the concepts individually. Let's first analyze the term called coupling. This term refers to the link between two or more components in a system that is extremely difficult to change. And how are these links created? You've probably created more than one on occasion without knowing it. One of the ways is through the magic word new, used in multiple programming languages, or when a new instance of a class is created. Tight coupling or high coupling means that related classes have multiple links created, which makes their maintenance extremely complicated. If there is any change in one of these classes, this change will propagate throughout the system, making it potentially difficult to understand and maintain. On the other hand, low coupling allows classes to be consumed and tested independently of other classes. Let's see coupling in action in Visual Studio. In Visual Studio, I have created a console project. The project contains only one class called program.cs, which allows us to handle the console to carry out printing of some words, receive user input, etc. In this specific case, I'm going to copy and paste a couple of classes that I previously created that will allow us to demonstrate this part of coupling. The first class is called person. This class contains only one property called name. We have a second class called printer, which is very simple. It just contains a method called print, which receives a parameter of type person and carries out the printing through console.writeLine. I'm going to quickly comment on this second class called printer, and I'm going to show you a tool that is part of Visual Studio that we can use to find out how coupling is as part of our code. If we look at the top, we have as part of the menu a tool called Analyze. We have an option called Calculate Code Metrics. We can calculate the metrics for our solution or for the project we currently have selected. I'm going to click on the option to perform the calculation for the current project. This displays a new window that we see at the bottom, which allows us to know some specific metrics. What I've done is disable the columns that I'm not interested in and only left enable this option of coupling between classes. Notice that as part of the coupling or as part of this specific window, we are shown the different components, different classes that are part of the system. We can see in a hierarchical way each of the classes that belong to this specific assembly and what is the coupling between each of them. For example, the person class, which we see on the screen, contains 0 coupling, a 0 value in the section that says class coupling. We have our class called program, which does contain a value of 1 as part of the coupling, meaning we have some kind of use of an external reference as part of this program class. If we review the program class, we see that we only have a call through console.writeLine. You might wonder why we have here a number that says 1 as part of the coupling, if we have not carried out the instantiation of a new class. A value of 1 appears because we are explicitly using this class called console and this method called writeLine. This indicates that we are creating some coupling between this console class and the class that is using it, that is, program or the program class, which we do not see explicitly as we did before, but it is defined behind the scenes. If we uncomment the code of this class called printer, notice what will happen. I'm going to press this button that will allow us to recalculate the metrics for the solution, and our printer class now appears here. This printer reference indicates that there is a value of 2 for the number of references we are using as part of this class. The first reference is given through this method, through the parameters of this method, that is, we are using here a person type parameter, and we are also using the console class again to carry out the printing of this person type object. We are using 2 different types of data as part of this printer class, and it is this number that appears here. It is a very simple example, but it allows us to see what happens when we are using external classes. We see how the coupling is being created. We may not even have realized that those links, that internal coupling is being created, and it makes maintenance a bit difficult if this system grows much more. It is a very simple tool to use that will allow you to obtain coupling very quickly. Another important point is that, for example, if I create a person reference here, let's call it P2 for example, equal to new person, here we are creating a new link to the person class again. However, when I click on this button to calculate the metrics again, this value 2 does not change. This means that, in reality, even though we are using this instance of the class twice, the actual coupling or that link we are creating between the printer class and our person class is actually a value of 1 since only one link is being created. No matter how many times you use the class, only one link will be created if it is the same reference to the same data type. You might wonder what the ideal number is to maintain as part of the coupling. According to some studies, some papers that have come out from people who have conducted research precisely on this topic, which is a quite interesting and strong topic for system design, the magic number, according to them, is the value 9. 9 should be the maximum threshold for coupling, for the number of classes that relate as part of a class as such. That is, you should have 9 different references that make up your class. And if you go beyond that threshold, then perhaps your class is performing some operations that do not correspond to that class. Basically, this is coupling. It is a very simple term to understand and also very easy to visualize. Now that we know what coupling is, let's look at the term cohesion, which is a bit less understood. We had previously said that systems should try to have high cohesion. Cohesion refers to how well integrated the elements of a class or module are with each other. This may sound a bit confusing, but let's look at it graphically. In this image, we see the members of a class internally. That is, we can appreciate some fields and methods that are part of it. But not only that, but we also see how the methods use certain fields that are part of the class, and we can even see how a method called method2 uses a private method called method3. Surely, with the mix of lines you can get a little confused and even think that the class has nothing wrong, but let's organize the members a little better. Now that we have sorted the members of the class, you have probably already noticed that there are two large groups in this class. A first group that is made up of a method that uses field A and field C, and a second group where field B and methods 2 and 3 are related. What does this separation mean? It means that method 1 and method 2, which are the main methods in this class, share very little in common, probably because we are giving multiple responsibilities to this class. This problem is an indication that our cohesion is low. Remember that we want high cohesion. What could we do to solve this problem? Well, the solution would be to split the class into two classes, with which both would achieve high cohesion, since by doing this, the members of each class integrate better. Let's look at cohesion in a practical way. We are back in Visual Studio. I'm going to compress these classes that we had copied and pasted earlier. And I'm going to copy and paste another section of code, or specifically, a different class. It is this class that we see on the screen. This class is called printer2, and look what this class does. It has a couple of fields, a field called logPath, a second field called filePath, and we have a couple of methods, one called print and a second method called log. Here, we're trying to simulate having a method that prints some kind of string or some kind of thing within a specific path. We also have a method that will be responsible for logging different messages so that we can use them throughout the application. And notice that this method does a console.writeLine and carries out the printing of the message, and also saves this message in a specific path, but this path is very specific in terms of the log path. So, you might think that this code is correct, that it has no flaws, it even compiles if you carry out the project compilation. But look here what is happening visually. We have our method called print that is using this field called filePath. And we have a second method called log, which is using a second field called logPath. This is causing our class to have low cohesion, and remember that the purpose is for our cohesion to be high in our classes. Let's see this visually. As part of Visual Studio, we have a tool called CodeLens, and specifically a tool called CodeMap. We can show a certain class in a CodeMap file that will display our class visually. Let's click on Show on CodeMap. And once this visual map has been created in which we can visualize our different classes, I will make this screen a little larger so that we can better see the content. Notice that this diagram shows us each of the classes that are part of the project, and we are specifically interested in the class that we pasted earlier called printer2. Look, visually, we are seeing the aspect of cohesion. We have a first method called print that makes use of this field called filePath, and a second method called log that makes use of this field called logPath. This indicates that we have low cohesion, since each of the members that are part of the class, or specifically the fields, are very closely related to some methods, but there is no relationship between the log method and the print method. What conclusion can we draw? The conclusion we can draw is that we are dividing or giving more responsibilities to the class than it should have. A first class should be in charge, for example, of carrying out the printing of certain content, and a second method should be specifically in charge of carrying out the logging part. To carry out some kind of record of failures or some kind of logging that we would like to have as part of the system. So, basically, this is what cohesion is about. These couple of concepts, both coupling and cohesion, are important to keep in mind when reviewing the different solid principles, specifically the single responsibility separation principle. Once we have understood the concepts of coupling and cohesion, we will learn about the single responsibility principle. If you want to respect this principle or apply it to your developments, you must follow two rules. The first one states that things that must change for the same reason should stay together. On the contrary, things that change for different reasons should be kept separate. Let's see this in a practical way. Suppose you create a reporting module for a web, desktop, or any type of application. As you know, to create this type of module, there are a series of elements that could be involved in creating the reports, such as a report involves a format, which indicates how the columns, rows, certain amounts in one color or a total in another color will look, or that several strings must be concatenated to build a formatted string, or that a number must have a currency format, etc. There are many things that can be related to the format of a report. If you have worked with them before, you surely know what I'm talking about. On the other hand, as part of the creation of the same reports, we can have some member or members who are responsible for performing different calculations to obtain different results in the report. For example, when calculating employee payroll, factors such as the days an employee missed work, the base hourly wage, the employee's position, some type of discount for withholdings, etc. come into play. Or we also have business logic that will dictate some rules for the company for which the system is developed, such as considering employee vacations for discounting or not discounting missing days. We see that there are indeed many tasks involved in generating reports. The question I want you to reflect on at this moment is, who is responsible for changing, for example, the format of the document? Or who is responsible for changing the business logic? Who is responsible for changing the calculation process? The answer is that the responsibility for these things or tasks lies with one person, a person who wants to make a change in the system to meet a real-world need. That is, our code will reflect that responsibility for each of those people who want to make changes. The single responsibility principle states that each module of our system should be responsible for only one person. At this point, you may ask yourself, hey Hector, but I'm the only developer because I am freelance or because my company does not require so much staff. Does it mean I can have all my code in one class? And the answer is no. I used this analogy of people to help you better understand what the single responsibility principle refers to, but we are actually talking about roles. When you are the only developer, you have the responsibility to take on different roles, such as the role of the person who will use the report, or the role of the database administrator, or the role of the person who defines the business rules. So, in reality, a module should be responsible for a single role, regardless of the number of people who perform that role. If, for example, we had to use HTML code to create graphical interface and SQL query code to handle database information, we should have at least two roles, one who cares about the graphical interface and one who cares about the SQL statements. What we should think about then is how we can isolate the modules so that if one person asks you for a change in certain functionality, it does not affect the other functionalities. Let's see this in action through a practical example. To better understand solid principles, I have created a project or an initial template. We will improve the code as part of this project and analyze each of these principles. Let's take a tour of this project so you can see what it's about. Basically, the purpose of this application is for the system to provide a result on a set of people who are affiliated with a certain sales system. An affiliate is a person who is responsible for promoting certain products, and if they carry out the sale of that product, they receive a commission or a percentage of the total sale. The goal of this application is for the system, based on certain parameters, to indicate the total amount due to that affiliate for a certain amount. We have here our initial project, our initial class, which is the program class. We have the program.cs file. Here we are simply carrying out the printing of a string that says starting the affiliate evaluation process and using a new instance of a report engine. This report engine evaluates a certain affiliate based on certain parameters, and finally the total commission for that affiliate is printed. It should be noted that this project will be available as part of the downloadable files for these cars. Let's examine a little more the other files that are part of this project. We have as part of the classes a class called affiliate.cs, which is the set of properties or is our model with which we will work throughout the project. This class contains a series of different properties such as the affiliate ID, the total sales made by the affiliate, the level of the affiliate, how many items the affiliate sold, and also the category that the affiliate sold the most. We will make this class public to avoid problems later on. Let's look at more files that we have as part of the project. We have an enumeration called affiliate level, which indicates the level of the affiliate. Based on the affiliate's level, processes are carried out to define the total percentage that corresponds to each of the affiliates. Let's look at a file called report.json, which contains the information of each of the affiliates. We have the affiliate ID, the total sales of the affiliate, the level of the affiliate, the number of items sold, and the category that has sold the most for this specific affiliate. Finally, let's examine the report engine file, which is the one that really interests us because it contains the business logic, or contains that part of the processing that we are interested in to find out how much commission the affiliate gets. The class called report engine has a public property called total commission, which is the property in which the total commission of the affiliate that we obtained after carrying out the processing will be stored so that we can print it from our class or from our program.cs file. Through this line that we see here, and let's go back to the file, we have a single method called evaluateAffiliate, where this processing begins by printing some strings as part of the console, such as starting the evaluation process. Next, we read the file that we saw earlier, that is part of the project. The file is called report.json. See that we're going to read this file, but we read it in string format, as we see here. Subsequently, through a JSON serializer, we carry out the deserialization of this information into an affiliate object, which contains the properties that are part of the file. In this way, we can extract the information from the file, place it in the properties of this object instance, and indicate the string that we will pass to carry out this deserialization. We see that the file is being read. We use a console.writeLine to indicate that the file was read correctly. We are using this console.writeLine as some kind of logger, some kind of mechanism that helps us know that certain processing was carried out. I want you to keep that in mind. We have a switch element in which we evaluate the affiliate's level to carry out different cases based on this affiliate's level. In the case that our affiliate has a basic level, which is the type of affiliate with a lower range, the logging of the calculation of the basic affiliate is carried out. A fairly simple calculation is carried out, where we indicate that the total commission for the affiliate is 15%. We multiply the total sales by 0.15 to obtain the 15% that will correspond to this affiliate. Subsequently, we evaluate the case of a silver level affiliate. We have some slightly more complex operations. We start by printing that we are going to carry out the calculation of a silver level affiliate. As it is a level higher than the basic level, here we can take into account certain additional values, such as if they sold a larger number of items to a specific number, we can give them a higher percentage, which is precisely what we're doing here. If the affiliate sold more than 10 products, then they will get a 25% commission, but if they did not sell more than 10 items, then we will give them a 20% percentage. This is because it is a silver level. The affiliate has done something more to reach this level of affiliation, so we will give them a slightly higher percentage. Finally, at a gold level, which is the highest level currently, what we're going to do is print that we are starting the processing for a gold level affiliate. In this case, if our affiliate has sold more than 20 items, then we give them the highest percentage, which is 50%. If the affiliate has sold more than 10 products, then we will give them 40% of the corresponding commission of the total sales. Ultimately, if they have not achieved these two goals, since they have a gold level as part of the affiliation level, we will give them 30%. These are very simple calculations, but they apply certain business logic to determine the total amount that each affiliate is entitled to. Based on this data that we have in the report.json file, which has a total sales of 1000 and a basic level, we will see how this application execution turns out. We have our window here, and it indicates that the affiliate's commission is $150. Let's change the level, for example, to a gold level. We start the application again, and in this case, the affiliate's commission is $500. However, we have some problems here as part of our processing engine. At this time, you can pause this video and start analyzing what those unique responsibilities should be for each class. It is correct to have this code as part of the report engine file? What do you think? I recommend pausing the video for a few seconds to reflect on this. We will continue discussing this principle in the next video. We are back in the Visual Studio project. I'm going to give you some hints about what needs to be changed as part of this project. First of all, we are carrying out some kind of logging through console.writeline throughout the project, but it is very common not to use console.writeline when it comes to slightly larger projects. This application could grow a bit more as the company we made it for grows. At some point, the person in charge of the project may not want to carry out printing through console.writeline of different strings that we are processing. Maybe later, the person would like to change this logging model for an additional tool that allows more control over those logs. For example, a tool that allows writing different files for each day the information is processed and keeps all the information available. We see that this console.writeline, for the purpose we're using it, has a strong reason to change. It is very separate from our report engine class that also has a specific task that we have entrusted to it. Let's start solving the project's issues. To carry out this task, I will add a new class, and we will call this class Logger. We already have our Logger class, let's make it a public class. As part of this class, I will define a void method called log. This method will receive a message, and as part of this message, I will simply indicate that I want to log through console.writeline, which is exactly what we were doing in our report engine file. Once we have done this, since we no longer want to use console.writeline as part of our class, we will create a new property of type logger called logger, with its respective get and set. We will even initialize a new instance of this logger. Once we have created our logger instance, we will change each of these console.writeline. We can select console.writeline since we know that the purpose of this console.writeline is to write messages to our logging system. So we can quickly replace it through Ctrl+H. We write console.writeline, the class name, the method name, and we will replace the code with logger.log. Throughout the entire document, I will carry out this replacement. In this way, 5 places were changed. In 5 places this replacement is carried out, And our file is ready with the corresponding replacement. We are no longer using console.writeLine to carry out the log or logs or that record of different events that happen throughout the application. We already have code that uses logger.log. The second step or the next task we should carry out is to analyze what else could change as part of our file. What is an additional responsibility that we are giving to our class called report engine that it should not have and that could change in the future? What I see as part of this file is that this section I am highlighting could change in the future. Notice that what is being done here is reading a specific file, in this case report.json. Then the deserialization is carried out through this method, converting it to an affiliate data type. What would happen if in the future this changed and the person in charge of this project no longer wanted to use JSON files? What would happen if instead they wanted to use, for example, a CSV file or a plain text file, or if they wanted to read some other type of file that could contain information, an Excel file for example? This could be a very strong reason to make a change in the system. Ideally, we should separate the responsibility of reading our file. As part of this responsibility, we could also carry out the conversion or deserialization of our object to an affiliate data type. What I'm going to do is create a new class called InfoReader. Once created, I will make it a public class and return to report engine. I will take a couple of lines and cut them. Then go back to InfoReader and create a method that returns an affiliate called readInfo. I will paste the couple of lines, importing the missing namespaces, and finally do a return affiliate info to return the affiliate information. In this specific case, I already have this reason that could change the file type, and also it is possible deserialization and conversion to an affiliate data type. I am removing this responsibility from report engine. Here, we obviously have some problems because the affiliate info type is no longer found. What I'm going to do is create a new instance of the InfoReader type, which is the class we just created. We will call this instance reader with its respective set and the creation of this object instance. Once we have this ready, we can go back to the line where we were before and indicate, for example, var and let this be equal to reader.readInfo. In this way, we solve all the problems we had before because we are already creating an affiliate instance. We can read its properties and we no longer have problems in our code. Let's check that everything works correctly, starting the execution of the application. Again, we are reading the file correctly and obtaining the commission of the affiliate we are evaluating. In this way, we have separated the responsibilities in our initial project. We have found that there have been two occasions for which the code could change. There are two strongly linked reasons. We have created new classes to solve this problem, and each class has its own responsibility. The strongest class is delegating the performance of small tasks to other classes to take care of the details. This class only takes care of what corresponds to it, which is processing the calculation of the affiliate's commission. So we come to the end of this principle. We will be taking it further as we move forward, but for now, I hope the single responsibility principle has been made clear.